QSO Today, episode 391, Fritz WB9KMO. My thanks to Icom America for sponsoring the QSO Today podcast. Welcome to the QSO Today podcast. I'm Eric Guth, amateur call sign 4Z1UG, where I demonstrate the diversity and relevance of the amateur radio hobby and its impact on society by interviewing ham radio operators, many of whom played vital roles in shaping our technology through the amateur radio hobby. And while many people might say, ham radio, do people still do that? This podcast demonstrates through in-depth interviews just how amazing, diverse, and dynamic the amateur radio hobby continues to be. Tickets are on sale now for the next QSO Today Virtual Ham Expo coming March 12th and 13th GMT in just a couple of weeks. I want to point out that the expo starts really at 6 p.m. Friday evening, the 11th, Pacific Standard Time. We have 3 live events that evening, starting at 7 p.m. Pacific Time, that include the Ham Radio Workbench podcast, the Ham Radio Happy Hour, and the Radio Amateur Training, Planning, and Activities Committee, or RATPAC. Click on the Expo banner in this week's show notes page for more information on these and more than 60 other presentations coming to the Expo that weekend. Fritz WB9KMO is a fixer and builder who is a pioneer in amateur television repeaters in the UHF and microwave bands, and now the Amateur Television Network, or ATN, a combination of amateur analog and digital television over RF links and the Internet. This network allows amateurs to share video over amateur radio worldwide. WB9KMO discusses the details of this history in this episode of QSO Today. WB9KMO, this is Eric, 4Z1UG. Are you there, Rod?
Hey, Eric, 4Z1UG. I am here, and you are my first DX contact of the year. Go ahead.
Rod, thanks for joining me on the QSO Today podcast. Can we start at the beginning of your ham radio story? When and how did it start for you?
Well, I'm going to go back before the beginning. When I was about 14 or 15, my parents told me one day that they had a big surprise for me. And I had been involved in technology for a long time. From the time I was about 7 or 8 years old, I used to go to garage sales with my mom. And I found that I could pick up radios that weren't working for like a quarter or something like that, and take them home and fiddle around with them, learn how they worked. Eventually, I got to the point where I could fix them and I could take them to sales and sell them for like $5. Wow, that was a lot of money in my pocket in those days. So that was the very beginning of the technology interest, and it just grew from there. But back to when I was 14, my parents had a surprise for me, and my mom took me on this ride. I lived in rural Wisconsin, and so we were just driving from farm to farm and went about 20 miles and pulled into this place, said, interesting. Okay, I was never much of a farm guy, so what the heck are we doing on a farm? And is this going to be a good surprise or a bad surprise? Anyway, we went inside. Lo and behold, in this bedroom was these 2 shiny radios. There was Hallicrafter's SX99 and some kind of a Johnson transmitter. I didn't know much about them at the time, but I knew they were ham radios. And my parents bought those radios for me at that time. And wow, what a memorable day that was. So I took those home, started playing with them. But it was a lot harder to get ham licenses back then. So
about when was that?
Well, that was about 1965-ish, 66, something like that. And so I started playing with the radios and learning about ham radio, and I was ready to take my license. In the little town of Waupun, Wisconsin, where I lived, there was only one ham that I knew of, and he was the father of a really good friend. But he was a very busy guy. I didn't have a driver license yet or anything like that. So I met him a couple times. I got to see his shack, but he wasn't much of an Elmer because I was out in the country. They were in town. And so he was kind of a guiding light, but he really couldn't help me get my license. I had to go, at the time, I would have to drive 150 miles to Chicago to get my license in Chicago. it just never materialized. So I didn't get my license for a long time. But in the meantime, I wanted to, have the feel of ham radio. And of course, I wanted to be legal. So I put a vertical antenna up alongside our TV tower. And I listened and listened and listened. And oh, man, I had a blast listening. But I always was compelled to transmit and knew I couldn't do it without a license. So I hooked up a light bulb to my AM transmitter, low power AM transmitter, and I transmitted into the light bulb as if I was actually on the air. And it was pretty cool to see the light bulb flashing to my voice. And I felt that I was really there. Of course, I wasn't making real contacts, but it was very exciting. And it was, I went to college at the University of Wisconsin in Madison when I was 18. And there I met a bunch of other hams and joined their engineering radio club, W9YT. And finally there, I had people who could really Elmer me, totally prepare me. And I finally got down to get my license in 1971 when I was 20 years old. And it was wonderful. I got my novice license first, WN9KMO. And I had that for about a year and just made a few contacts because I wasn't that much into CW, but, it was an important first step.
You're a little bit older than I am, but I remember swap meets. And the radios that we would find at swap meets were these 5-tube super heterodyne radios, and they came in all forms and different kinds of bakelite or plastic cases. Were those the kind of receivers that you were finding at swap meets?
I was finding some of those, but that was kind of their heyday, and those were the current radios. In Wisconsin, we later called them barn radios, but I think they were referred to as the Classic 5 or something like that. Now, a lot of them that I was dealing with were even some of the big floor size radios and much older radios. I remember one that I had that I really loved was a floor mount thing that was about 3.5 feet high and 2 feet wide and about a foot deep or so. And it was a Majestic brand. I remember that. And that, oh boy, it sounded really good. And when I fixed that one up, I kept it. I had the whole basement of the house to myself. So I could have junk strewn everywhere and 100 projects going on at the same time. Yeah, they were mostly older radios than that. If I was lucky, I would get one of those 5-tube radios.
Those old floor radios had huge speakers, too. I mean, they were really hi-fi.
They sounded amazingly good. And one of the things that people don't know about those old radios with the big speakers is they didn't have very good permanent magnets at the time. And so they used electromagnets in the speakers to power them, to function as the magnet. And those speakers, the coil in those speakers was generally an inductor in the power supply, the DC supply. So, you didn't want to go poking around that speaker. It wasn't like just an 8-ohm thing with audio on it. It was like, 300 volts or something on the speaker coil. Of course, if your power supply had hum, then your speaker had hum too. But they were big old speakers, some of them a foot in diameter, and they gave pretty good bass response. And they were glorious at the time. By today's standards, they aren't quite as good. Back then, they paid a lot more attention to quality, I think, than they do now. Now it's like, how cheap can we make this? And how portable is it? We've got these little 1-inch speakers that we use. And so there was a certain elegance about those old radios.
In the news recently is, Neil Young bailing out of Spotify because of something that Joe Rogan might have said on one of his podcasts. But Neil Young has been battling Spotify for years over the bandwidth of the recordings that these digital media companies are putting out, because he says they don't have the frequency response that people are used to hearing. But nowadays, this electronic stuff that we listen to is limited bandwidth, and maybe we don't know the difference anymore unless we're had an ear for it. Maybe this generation, the younger generation that's now listening on phones and stuff, has never heard this big concert sound that used to come out of these systems.
Yeah, and there is good quality stuff around, but most of the consumer stuff is aimed at making profits and presuming that people don't care. And to some extent, a lot of the younger people have never experienced good quality sound. Even some of the good venues, like you go to IMAX and things like that, they go a long way to give good quality sound. But
sometimes it's so loud.
Yeah, it distorts your ears. There's no distortion in the music, but it's so loud it distorts your ears.
Right.
So they get a taste of that. And one little side comment, it's not only in technology. I'm a foodie. I just love to eat. I can't cook with beans, and being an old timer where I grew up on kind of a gentleman's farm, we had big gardens and stuff with fresh fruits and vegetables all the time. I love to just, go out in the garden, pick a tomato with the salt shaker and eat it there. And it doesn't get any better than that. Well, now they're genetically altering everything. And, it's really good for travel, but you might as well be eating a baseball. And because of that, the new generations aren't exposed to the really good quality food that we used to have. And it's really hard to find good food. And, the ultimate end to this whole thing is something like Soylent Green, which is, and for those of you who are listening to this, who never heard about Soylent Green, go and rent that video or watch it on Netflix or whatever, and you'll see what I'm talking about, where people don't know how the food was processed that they're eating, and they think it's the best thing in the world, but it's far from it.
What people can try is they should try to grow cherry tomatoes in a pot, and then they'll discover what a tomato is supposed to taste like.
Right, and try to make sure that you get seeds to grow them that were not genetically altered, because when they're genetically altered, they very seldom do that to improve the quality and the taste and even the food value of the food. It's all about transporting it efficiently, and that's why you don't get ripe things in stores. You get things that are not ripe. They probably never ripen. And anyway, but the point is that as we move on, you have to be careful what path technology takes you down. There are some wonderful paths, where things really improve. Often there are trade-offs, and we may talk about digital TV, for example, and things like that. I'll talk more about some of the trade-offs, but there's some real benefits too, and real benefits for the consumer, the end user. And then there's another path where the benefits are not for the consumer. The benefits are for the vendor, who can transport things more easily and make more things.
Or in the case of music, for example, we're trading convenience, the ability to carry thousands of songs in your pocket, versus the concert hall kind of sound.
Yeah, and MP3 is an example. And the point here is that MP3 is dummied down digital music. It doesn't have to be. It's all about the sample rate and things like that. If you have an adequate sample rate, you can have beautiful sounding digital music. Ultimately, you can get to the point where even the purest ear probably can't distinguish the difference. But the way that they publish MP3 music, I can't stand to listen to it. It's like fingers on a blackboard. And other people are affected that way too. But then there are a lot of people that just don't know any better, and they think that's what good quality music is.
Well, do you think, Rod, before we move on to the rest of your story, do you think that as the cost of hard drive space continues to plummet and the bandwidth that's available to us on our home connections, I'm now on fiber with a gigabit Ethernet down and 100 mega up, which is very cool for me, that with the explosion of the available bandwidth, maybe 5G will give phones even more bandwidth, that we'll actually get back to having MP3s at higher sampling rates and higher quality?
Or not requiring MP3s, having a high sample rate digital rendition that sounds just as good. We certainly can do that, and I'm quite sure that there will be people out there that really care about the quality of things that will make that available. But so many people kind of get stuck on these inferior technologies, actually, that were put together for practical reasons at one point, like you said, because low bandwidth was required for the storage space that was available, and they just get used to doing that, and they perpetuate these bad technology techniques, thinking that that's the norm, and that's as good as it can be. But just like good food will always be available if you seek it out, and when you get good food, if you're like me, you appreciate it so much. Like, it's nirvana, okay? And the same thing is true for technology. And I'm not saying that the old way is always the best, but there are certain purities that you want in music, for example. And I've been involved in music for quite a while, and I really appreciate good music. And again, for me, I'm passionate about it. You can probably tell. And it's like nirvana to me when I can sit down and listen to even live music. Oh boy, that's wonderful. And to see people performing pretty much perfectly in a live venue. And I'm not talking necessarily about loud rock and roll. I certainly appreciate classical music and all kinds of music. And to get to experience music the way that it was kind of intended to be, and being produced in a very professional way, I just love it. And so that goes for technology too. You don't have to have it all the time. Sometimes the convenience is well worth it. It's kind of nice to be able to have this little phone and carry the phone around, and we can get into that later. But these cell phones that we have now are amazing pieces of equipment. Now they aren't as elegant in producing, actually they produce very good video, and they can handle audio pretty well too. And it's amazing what the speakers can do in here. But the headphones that are available, you can get very good sound out of it, as long as your source is good. But we can get into this later. This thing I'm holding in my hand, my Android cell phone, is one of my favorite amateur radio. Okay, it's come a long way from the Hallicrafter's SX99, but I actually use my cell phone as an amateur radio. So that'll segue into something later.
And now this message from Icom America. Spring is just around the corner, and Icom's new ID52A handheld is now shipping. The Icom ID52A is an industry-first handheld that can send photos over the D-Star network. This radio is perfect for working your favorite VHF and UHF bands inside the ham shack and venturing outside. Did I say that Icom's ID52A is now shipping? Icom's newest handheld amateur radio is a VHF-UHF dual bander with D-Star and FM dual mode functions. This radio supports conventional FM communications and D-Star simplex, repeater, and regional and worldwide calls over the D-Star Internet Gateway. The Icom ID52A is the first handheld amateur radio with a full-color 2.3-inch waterfall display that can send photos over D-Star with connected Android device. Other features include wideband receiver with a guaranteed range of 144 to 148 MHz and 440 to 450 MHz, VV, UU, VU with dual DV mode, integrated GPS or GLONASS receiver, including grid square locations, micro SD card slot, micro USB for data transfer, programming, and charging, and it's IPX7 waterproof and rugged. To get your Icom ID52A or any fine Icom transceiver, visit your local ham radio dealer. Click on the banner in this week's show notes page. And when you finally buy that Icom radio, be sure to tell your dealer that you heard about it here on QSO Today. And now back to our QSO Day. When you were at the University of Wisconsin, what did you study?
I studied electrical engineering. I always wanted to be involved in technology. Electrical engineering seemed like the path I wanted to take until I got into it. And I kind of regret I never got my degree. I didn't like the way they presented the education of electrical engineering. And I won't get into it too much. And I I loved math too. It was a lot of it was about math, but a lot of it was just the way they did things, especially the first couple of years. They had you doing things that were not interesting at all, and it was hard to see the relevance. And that was true and probably still is today in a lot of education. They don't teach you the things that you really need to know. They teach you the things they want to teach you.
There's a lot of casualties you should know. Amateur radio operators who had this idea what electrical engineering should be, and I'm one of them who got to college and found that it was completely different, or it seemed completely different at the time.
And now looking back, I regret not finishing. I should have just stuck it out. But I've always been kind of in a hurry to do the things that I want to do. And I'm a hands-on guy. I like building things, fixing things, and operating. A lot of hams have their little specialties. Some people build things and never operate. Some people operate and never build things. But I like all facets of it. And in electrical engineering, I wasn't able to do any of that in the first couple of years. And that spoiled me. And it's kind of a shame.
Where did your life take you after that?
Well, it's kind of funny because I've been really fortunate, some of the things that happened to me. And, maybe I had some influence on my decisions, but I've been kind of blessed in things that were, dumped on my doorstep for me. So I'm a hands-on guy. I wanted to do things. Well, first of all, I'll go back to college. Okay. In college, I didn't do very well in electrical engineering because I didn't apply myself. And, but I worked at a student radio station, and that was wonderful. I had my hands on. I loved music, and so I hung out with these guys. And in the 2 years that I was there, I became a DJ, and I became an engineer for the student radio station. Ultimately, the chief engineer for the student radio station. And we actually we operated carrier current transmissions into 6 dorms. We had 3,000 listeners in 6 dorms. And for carrier current, basically, is we took an AM broadcast transmitter and we coupled it into the power line of these dorms. So the power lines were our antenna. And the intention here was we didn't radiate very far, but radiating from the power lines in the dorm, any radio within 100 feet or so would receive a signal. And we operated this like a regular broadcast station. In fact, our main transmitter was a 500 watt Gates commercial AM broadcast transmitter with the big tubes, and we loved how they glowed red and all of that kind of stuff. So I was hands-on at that radio station, and I got far more out of that than I did out of my electrical engineering classes. And I probably should have gone into broadcasting and had several opportunities to do that. I can talk about that a little more later. But when I gave up on electrical engineering after a couple of years, and I decided I wanted to get a job where I worked with electronics. And this was in 1971. And I'd gotten my ham license by then, but there's didn't seem to be any money to be made in ham radio. That was just a fun hobby. And so I was looking to become a television repairman. That was what I intended to be for my career, at least at the time. And I went down to the Wisconsin Employment Department, and they operated differently back then. They tried to get you jobs. It wasn't all about getting unemployment for sitting around and just collecting money. So I I met with them, interviewed, told them what kind of job, what kind of background I had, what kind of job I was interested in. I told them I was looking for maybe an apprenticeship with a TV repairman. And I told them, explained, I know how to fix these things already, but I don't know how to make money as a business with it. So I would have been totally excited if they would have found something like that for me. But they couldn't find any TV repair for me. However, I got this phone call one day. I think it was only about a month later. And they said, we realize you're looking to get into TV repair, but we have this company out here that needs somebody with your skill set. And it happened to be Burroughs Corporation. And the interesting thing about it was they offered me a job, but the job was to work on mechanical machines, because at the time there were a lot more mechanical business machines than electronic ones. Even the big accounting machines had all these levers and stuff that went back and forth, and they had mechanical memory in them, and they were just starting to get into electronics. So I became an adding machine tech for Burroughs, and what I found out, which was interesting, is even though I worked on mechanical adding machines, the reason they wanted me was because of my electronics. And I didn't know it until later, but I was the first person that ever got everything right on their electronics. Now, even though I did poorly in electrical engineering, I knew electronics. Let me step back for a second. I was very fortunate being in Wisconsin. I had a wonderful high school with incredible teachers. And one of the things that I had that was a true blessing was I had 3 years of electronics in high school. There were only 2 schools in the state, and I'm in a town of 10,000 people. You know, how was I so fortunate to get this? And it was just fantastic. So by the time I got out of high school, I knew electronics very well, including tubes. We taught tubes. We built things, and we learned about transistors, and we built things with transistors. And in 3 years, I learned a lot. So that really spoiled me. So when I got into electrical engineering, electrical engineering looked that much worse, because I had already had 3 years of hands-on things, and I had all of this knowledge that I couldn't apply. And so anyway, I had a lot of aptitude in electronics, and that's why they were amazed that I did well on this exam. Still, for a year or so, I just worked on these mechanical adding machines, and I was good at it. You know, it was like I worked on some adding machines that were 80 years old, these old mechanical things, hand crank things, and repaired them, maintained them, and I was happy enough to do that. It was challenging, and I was good at it. But eventually, they started getting electronic calculators in, and there was only in that shop there were probably 15 techs. There was only one other guy that knew anything about electronics and could fix these. But I wasn't trained on them either. And we repaired everything to the component level. We didn't swap out cards. In fact, back in the day, an electronic 4-banger calculator that add, subtract, multiply, and divide cost about $2,000, $2,500, and it was these were Sharp calculators that were built to Burroughs specs. They had Nixie tubes in them, the little glowing tubes with numbers inside. For those of you that don't know what Nixie tubes are, Google Nixie tubes. So they were pretty valuable machines, and not every bank had those. You know, they had a lot of the mechanical stuff, and they had a printing calculator too. I'll talk about in a minute. But my point is that those calculators were about 1.5 feet wide, 1.5 feet deep, and maybe 6 inches high. And I don't know. I don't remember how many digits they had, 6 or 8 digits on them. And they did everything that simple calculators do today. But the circuitry was all on one board. And it was mostly resistors and transistors and discrete components. And when something went wrong with those, we had to isolate the problem to the component level. Usually a transistor went out or something. And actually, they were quite reliable, as it turned out. And we unsoldered the part, soldered a new one in, and away we went. Nowadays, they just replace the old calculator.
But they were amazing at the time. They were a wonder, I think.
Oh, yeah, compared to the mechanical things. And one comment about the printing calculator, they still printed on a 2-inch wide paper tape. And those printing calculators at the time were about 2 feet wide, 2 feet deep, and 1 foot high. They had displays on them, the Nixie displays and the normal keyboard, but they had this big top surface, and there was just little 2-inch wide paper tape on it. It was like hilarious to see this. And they sold those for $4,000 when they first came out. Eventually, the prices went down. So anyway, I was one of 2 people that could repair those. So the people that couldn't work on the electronic stuff had ended up working on the mechanical things. And then the couple of us that could work on the electronic things were pretty busy with the electronic ones. And the beauty of that was after about 2 years with Burroughs, our Burroughs branch office split. And when it split, we had two guys that worked on computers at the time. And it was a Burroughs 5500. I think there were two of them around, and one of them was at the University of Wisconsin. And at the time, I wasn't working on those computers, but these two guys were. And when our branch split, we split so that the smaller business machines were taken over by our Minneapolis office, and the computer electronic stuff was taken over by our Chicago office. And since I was working on both things, they couldn't split me and take me both ways. And so they sent me, fortunately, down the electronics path. And that really opened up my career to be working on computers and going down the computer path rather than staying with mechanical things.
You also moved to Santa Barbara, California. So how did that happen?
I worked for Burroughs for 8 or 9 years. And what happened, I started with Burroughs in about 71, so maybe it was only about 6 years. 8 or 9 years total, because some of it was in California. I'll get to that. So in Wisconsin, I worked for Burroughs for about 6. And I had gotten to the point where I was pretty much one of the world-class techs working on what they called magnetics at the time. And those were disk drives. And, I had worked on several generations of those, and they've gotten smaller and smaller with more and more storage. And I was considered an expert on them, so that they sent me lots of different places out of town to fix them. And also magnetics were magnetic tape machines. And you see a lot of these magnetic tape machines on old sci-fi movies because they have all of this motion in them, and they had vacuums that sucked the tape down and buffered the motion of the tape. And the sci-fi movies made them look like they were the computers that operated the spaceships, which pretty laughable. But they were kind of cool to look at, so they were good in the movies. Anyway, so I was an expert on all of those things, and I was very good at fixing the computers too at the time. But the problem was that I was one of 3 computer techs there, and there were 2 older guys there, and they were going to be there for the next 30 years. And so even though I was pretty good at this stuff, my advancement opportunities were very limited. So what they wanted to do, especially because my branch office was in Chicago, they wanted me to move to the big city and take my skills there. And in fact, I worked a lot remotely at the Federal Reserve in Chicago. They sent me there to work on big check sorter machines that read in all the checks and flipped the magnetic blade back and forth to route them to different pockets. Each one of those machines actually cost $250,000 at the time. And we had our banks in Madison generally had one of those that they could use. And so I was, pretty good at fixing those too. But the Federal Reserve had, dozens, or I don't know how many they had. They had a room that was so big you couldn't see the other end of it, and it was filled with these things. Because at the time, any check that you wrote was routed to the Federal Reserve, processed at the Federal Reserve Bank in Chicago or another regional bank, and then sent back to you the physical check. So before all this electronic money stuff, that's how they did this. It was a very inefficient process, but everybody expect to get back their canceled checks, and so they can see the process that they went through and everything. So I had spent a lot of time down in Chicago working on that, but I told them I don't like Chicago. I don't want to go to Chicago. And I had gone to training sessions in California, and boy, I loved California. And if you're from Wisconsin and you get a chance to go to California in February, which I had a 1-month training session in California in February. And that was the end of my days in Wisconsin because I had determined I'm moving to California somehow. So I actually talked them into moving me to California instead of moving me to Chicago. And I'll keep the long story short. I was supposed to go to one place, and they said, no, we'd rather have you in this place called, they really need you in this place called Goleta. And I said, where's that? And they said, oh, Goleta, that's the little town right next to Santa Barbara. I said, oh, that's too bad. And I'd been in Santa Barbara. I said, oh, man, it's really expensive to live there. And the people there are so crazy. They put stop and go lights in the middle of the freeway. And they actually did that in the middle of Highway 101. Everybody's zooming. As you're going through town, they had 3 stop and go lights there. And they would turn red and they would hold up traffic. And the whole idea was they didn't want people zooming past Santa Barbara. They wanted people to stop and go to the beaches and see all the mountains and the shops and all the wonderful things there. And I understand that, but it's a little bit insane to put stop and go lights in the freeway. So I really had a bad taste in my mouth about Santa Barbara.
But you could swim off the point in Goleta Beach in February while everybody in Wisconsin was freezing, right?
Well, actually, the water in Santa Barbara is very cold. And my kids went out in it, but always wore wetsuits to protect them. The only people that swam in their skin, especially in February, were the people from Wisconsin who found it warm compared to swimming in an ice-filled lake.
Well, I did it.
Okay.
I was telling Rod beforehand that I went to UC Santa Barbara about the same time that he was there. So, yeah, there was a group of us that would go out at lunchtime, and we weren't in very long, but we swam all the time.
I loved the beach, but I didn't get out in the cold water very much. And I loved the mountains a lot more. But wrapping up my move to Santa Barbara story, so they said, well, just come out. We'll show you around, and we'll show you that it's really a wonderful place to work, and we really need you out here. And they really wanted me. I didn't know how valuable I was at the time. But so I went out there, and it was a wonderful place. And the guy who was going to be my boss was from Michigan. And he was just a really nice person. And I knew a couple of the people that were already there because I had gone to school with. And so, I was kind of sold on the place. But in Madison, I was ready to buy a house, and I had the money saved up. And I was like all ready to go. And there was no way I was going to buy a house in Santa Barbara because things were so expensive. So I told them, well, I really like it here, but I can't afford to live here. Maybe if I made 30% more or something, I slyly tried to talk them into giving me a big raise. Well, they came back a couple of days later and they said, we really want you to move here. We can't afford to give you 30%, but we'll give you an 18% raise if I come here. So they sold me on it, and I moved to Santa Barbara, and I loved Santa Barbara. I lived there for 35 years. And so that's how I got there. I worked for Burroughs there a couple of years until and I was working along with the engineers there, hands-on, okay? I was writing technical manuals, and I was building and testing prototype computers, mini computers at the time. And the engineers that I worked with were wonderful people, and we got along really well together. And I was having a lot of fun. I was working on a very high technology computer at the time, and people will laugh now. It had a clock rate of 40 megahertz. 40 megahertz, that's really fast. Nowadays, 2.4 gigahertz clock rate, well, things have changed a little bit. But at 40 megahertz, Burroughs was making their own components, and they were having trouble getting reliable components built, especially the large-scale integrated circuits. And they were looking for a second source, and they could hardly source the components themselves, even to build the prototypes. Well, it turned out the two companies they were trying to get to second source backed out. And without a second source, they couldn't produce that computer. And that whole project got scrapped. And so that was a lot of fun working on the high-tech project. And then they tried to get me to work on lower-tech projects. There was no turning back for me. I didn't want to work on that kind of stuff. So I ended up leaving Burroughs after a couple of years. And then I got into microcomputers. I worked for a place in Santa Barbara called the Computer Shop. And I had worked with 8080s at Burroughs because we built a console. We called it a console. It was the console is what connected to the computers so that you type things into the computers and you got information back. And so I had experience with 8080s. And so I could see that there was a future in this microcomputer thing. And I got involved in that. It was a very exciting time for computer technology. They had every year, I actually heard they're still doing this. I've got to check into this. Every year at the time, and this is the later 70s, around 1980, there was a convention in the San Francisco Bay Area called the West Coast Computer Fair. And I went to that West Coast Computer Fair religiously every year. And they had computers that were based on S100 boards. They were boards about a foot long, 6 inches high, that plugged into an S100 bus because it had 100 contacts on it. And they were notorious for having contact failures, which is what's a big problem with those. But they had replaceable cards, and you could put in memory cards and IO cards and all kinds of different cards to plug into this bus. And that technology was around for a while. Yeah, CP/M operating system was popular. There were a bunch of other proprietary things, pet computers and things like that at the time. About that time, these guys up in the Bay Area started putting together this company called Apple. When I switched over to microcomputers, I became an Apple dealer, and these were in the Apple II days, and that was a lot of fun. But they weren't used a lot in business. They were more hobby computers at the time. I worked on other computers that were larger. The key one was called Alpha Micro at the time, and they had bigger disk drives, and they were used in business. In fact, one of my early customers in Santa Barbara was Kinko's Graphics. And Kinko's...
The original.
Yep, the original.
Isla Vista was the first Kinko's store.
That's right. And I maintained their computers at the time. And it was a very interesting organization. It was kind of a garage operation at the time. And little did I know what they were going to turn into. And they grew and grew and grew and spread across the country. And some of you have had experience going to Kinko's Graphics. I'm glad to see that they did really well.
Are they still around?
I think they were bought out by Federal Express or like that. All of the people that were involved at that time would be my age or older. And so I presume that they sold out, liquidated, and kind of retired.
If you went to UC Santa Barbara, that's where you got half your books, because professors would Xerox all these pages and put them in book form and send them to Kinko's. So you'd go to Kinko's to buy half the books that you want. What did you do in amateur radio when you're in Santa Barbara at the time?
Well, actually, I should go back to Wisconsin for amateur radio because I was a ham in Madison. I apologize for those dings my computer is doing. So in Santa Barbara, I got my license, in Madison, Wisconsin, I got my license in 1971, a novice for a year. And then I jumped from novice to advanced. I just took my test and got my general and advanced all at once. And so then that allowed me to operate HF, and that was cool. So I bought Heath kits and built Heath kits, and I was on HF, but I never had good antennas. The first radios that I had were 2-meter radios, and I worked the 2-meter repeat. And I think I had a standard HT that I got, and I built an early Heath kit 2-meter radio too. But I wasn't satisfied with that. I was always interested in the bleeding edge of things. Still am today, actually. And the bleeding edge at the time were things like facsimile. Now we know it as fax, but back then it was facsimile. And facsimile was interesting because it wasn't like anything today. It basically, you had a machine that burned paper to put text on a page. And of course, we had teletypes, Model 19 teletypes, old big floor standing things that shook the whole house when they operated, and they would type a character at a time on this. So I wanted to check out all of these specialized modes at the time. And I did, so I got this and that and the other thing. And then About 6 months to a year into doing that kind of stuff, I got the ATV bug. There were no ATVers around Madison at the time. There were some in Milwaukee, but I didn't get to Milwaukee. So I kind of learned this on my own. And I basically had a good friend who was a ham friend in Madison. And he's still a ham and a great guy. And, I kind of dared him. I said, this TV stuff looks really cool. And I want to get into it, but I need a partner that I can send and receive pictures to. So I dare you to get on ATV with me. And it took us about a year, and we got our act together, and we were about 6 miles apart, and we were gladly sending video back and forth.
I want to take a minute to tell you about my favorite podcast, the Ham Radio Workbench podcast, with George, KJ6VU, and now joined by Rod, VA3ON, Mike, VA3MW, Mark, N6MTS, and Vince, VE6LK. Every 2 weeks, George and company offer up a status report on the many amateur radio projects on their workbenches and explore projects on their guests' workbenches. This group is project active and prolific, covering many technical areas of amateur radio. So the next time you want a deep dive into ham radio electronic project building, or to learn about technology, tools, test equipment, construction techniques, and the rest, listen to the Ham Radio Workbench podcast, available on every podcast player and channel. Use the link in this week's show notes page to get to the Ham Radio Workbench podcast directly. And now back to my QSO. When I was a kid, Rod, ATV, or at least it appeared to us at the time, that was slow scan television, robot on HF. Is that the same thing as what you're talking about now?
No, but it's good that you brought it up, because when I was going through facsimile and radio teletype, slow scan TV caught my eye. That was another specialized mode, and I wanted to operate that. Again, very different from the way it is right now. Back then, slow scan TV was displayed basically on an oscilloscope tube, 5 to 7 inches in diameter. And oscilloscope tubes have a characteristic called persistence, and that's how long the tube glows when the electron beam hits it. And oscilloscopes had short persistence because you wanted beam racing really fast so you could see instantaneous changes in things. But they also had long persistence oscilloscope tubes that had what was called a P7 phosphor. And you could actually put the P7 phosphor tube into a regular oscilloscope if you wanted. And the P7 phosphor kind of glowed, instead of instantaneously going black after you hit it, when you hit it with a beam, you could see that beam slowly fade away over, I believe, 7 seconds. I think that's why they called it phosphor. So it's hung around for a while. And that's what was used for slow scan TV to display it, because you would display a raster of information across that tube. So you display a whole picture. The fastest mode took 8 seconds from the top to the bottom to display a picture. And it would scan line by line. And so it would start bright and then slowly fade away. And you had to rely on your memory a little bit so that you could envision the whole picture, because by the time you got to displaying to the bottom of the picture, the top had faded to black. But you could display still pictures that way, and that was a lot of fun. And nowadays, then they got to the point where they built computer interfaces. You could display it on a monitor screen, and you could store the image in memory. You could display the whole picture.
You decided not to do that instead?
Well, no, I decided to do that. I did it for quite a while. I really enjoyed slow scan TV, but it wasn't enough. Picture's worth 1,000 words, but video is worth 1,000 pictures or 1,000,000 words. And so ATV was the most exciting mode that I could imagine. Now, one other specialized mode that I operated, and I still do a little of that today, I want to get more into it, was satellite communication. That was a blast. So radio amateurs at that time in the 70s had typically only one, maybe 2 satellites in the air at a time. And some of them worked pretty well and some of them didn't work very well, but you could transmit to the satellite, even sideband, and get the signal repeated back. And the fun thing about that, it seemed like there was about a quarter-second delay. So you could hear your signal coming back a quarter-second. Oh, man, that was exciting, being able to transmit ham radio into space, have it come back. I never quite got into moon bounce. That was too big of a challenge at that point. But that appealed to me. I just couldn't see my way to doing that. So anyway, at the time, the most exciting mode for me looked like it was going to be amateur television. And so I jumped into it with 2 feet. And my first ATV transmitter was an RCA CMU model CMU15. You can Google that. And it was basically an FM radio, but across the country, radio amateurs had had a fair amount of success converting those into amateur television transmitters. They weren't perfect, but they worked pretty well.
In those days, what was the amateur television bands? What bands were you operating in to do amateur television? Because you needed a fair amount of bandwidth.
Yeah, we were never allowed by regulations to operate below 420 megahertz. And so we were primarily on the 420 to 450 megahertz band. And in fact, in the Midwest, the ARRL helped coordinate a couple of frequencies. At the time, they were 439.25 megahertz and I think it was 427.25. The bottom frequency changed around a little bit. And at that time, there was only one ATV repeater existing. And this was in the mid 70s. I got on ATV in about 1975. Somewhere around Washington, D.C. or Philadelphia, some people had put an ATV repeater on the air. And I presume, I don't remember the details, but I presume it had like a 439.25 input and a 427.25 output, all within the band, which was challenging because when you have an 8 megahertz wide channel, if you get the input and output too close together, they interfere. So you have to have a very good filter. So to answer your question, the 420 band, originally everybody used modified FM radios, tube rigs. And, we were getting 10 watts out. So we had reasonable range. We could transmit 10 miles with them, with a gain Yagi antenna. And then we wanted to get solid state things, but the solid state rigs, FM rigs at the time, were pretty narrow banded. So we couldn't get very good quality video out of the converted solid state FM rig. But, it was a lot of fun at the time. It was definitely the bleeding edge. And that was 1975. And keep in mind, in 1977, I moved to Santa Barbara. But soon after I got on ATV, I got this ATV repeater bug. And I said, oh, that's a great idea. You put this repeater up at a high point, just like an FM repeater, and people can transmit their video in, and it gets retransmitted from a high antenna. And you can get a lot more distance because you were limited to line of sight at the 450 band. And so I started building one, and I had it about half done by the time I moved to Santa Barbara. And I loved Madison, Wisconsin. To this day, I love it. I wish they had decent weather there. Maybe with global warming, I might move back someday.
You can only hope.
Yeah. So that takes me to moving to Santa Barbara. And I carried this half-finished ATV repeater to Santa Barbara with me, and I found out there was nobody on ATV in Santa Barbara. And there were only a couple people on ATV even in the LA area. So I started talking to those guys. And by 1980, I had my ATV repeater on the air at the KTYD transmitter site, 2,500 feet elevation in the mountains above Santa Barbara. And that was 1980. That ATV repeater is still operating today, 42 years later. I'm very proud of it.
That's amazing. Is same equipment?
Oh, no. In the early days, we used, to make the repeaters more efficient, we used the 450 megahertz band for ATV inputs. And in California, especially, it was really hard to get the bandwidth because there were so many repeaters and remote bases on the 420 band. So the frequency coordinators required us to move our repeater outputs to the 1200 band. So mine was 434 megahertz in and 1277.25 megahertz out. in 1980 when I built the first repeater. And the transmitter that I used was a 450 transmitter into a varactor tripler. And the varactor tripler then was a very non-linear device, and you need linearity for television. So it was pretty crude, but it did work. And so with 10 watts in on 450, I'd get about 1.5 watts out at 1277. And to my surprise, the first contact that was made through my repeater was from San Diego. There was a guy with a great station and a great site down there. And over the water, the propagation path was very good at the time. And he had a very nice picture into my repeater and received a very nice one back. And I wish I could remember his name and call. I'd love to give him credit for that.
That was about 200 miles, too, that path.
Yeah, about 200 miles.
That was very impressive, yeah.
I had a 1.5 watt output signal on 1277. That was so thrilling. And we've come a long way since then. I want one more comment about the varactor. Varactor is a solid state device, and it's basically a diode. And when you hit diodes with RF, they just hack it all up because they generate a lot of harmonics. That's the key point. The harmonics then go up and up in frequency, and the third harmonic of the 450 band was the 1200 band. And that's why it was practical to get energy out there. Well, at the time, the varactors that would cover that power level were very expensive and hard to get. And so what we did instead is we stacked a whole bunch of 1N914 low power diodes in parallel. I don't remember how many it took to dissipate 1.5 watts, and well, actually, it dissipated more energy than that because it was so inefficient. So we used a whole stack, I don't know, maybe 24 1N914 diodes in parallel as our varactor, and it actually worked. So we've come a long way, baby.
And what's there now?
Over time, Mitsubishi came out with some bricks that are really big, high-powered ICs, and we use those for amplifiers. We can stack several of those in parallel, and they've gotten more linear over time. So right now I have a 4-brick amplifier there, and it puts out about 22 watts of output and around 80 watts or so peak power. It covers the area very well. It's also linear enough so that same amplifier will work for digital ATV. And so we're in the process of converting the output to digital. The advantage there, main advantage, is that we can go high definition rather than standard definition, get a much better quality picture, and virtually noise-free. I mean, I could go on and on about the technology of that. There's some very significant advantages to digital. There are some advantages to analog TV too, and analog TV may in fact be used for DXing for a long time because you can see the signal with very weak signals if you transmit analog TV. If you transmit digital TV, you don't see it until it gets a little bit stronger, and then all of a sudden it's almost perfect. And it's that level of perfection at a relatively low power level that is a key advantage to digital. But the DXers still like analog, and their contacts. Well, I could tell you about receiving analog television in the LA area from Hawaii, 2,200 miles away.
Because of the inversion layer.
Yeah, the inversion layer over the ocean. It's called ducting, and it's like having a coaxial cable, and it's like having an ideal coaxial cable. It's lower loss than a coaxial cable would be, and Gordon West, I believe, was the first one to receive that beacon that's out in Hawaii, and I believe that beacon's still operating, and it's analog, and people like to monitor that from time to time. Can't see it all the time, but every once in a while the propagation opens up, and there it is. And it'll be a long time if ever they are able to see digital TV from there. So there is a distinct advantage on weak signal work for analog television. But digital, we're going digital now, and that's the way to go for several reasons.
What's ATN, Amateur Television Network?
Amateur Television Network is a group of people interested in amateur television. It started up in Southern California. Around the time that I put my repeater on the air, a guy named Mike Collis, WA6SVT, who was just a kid at the time. At the time he put up his first repeater in 1979, about a year ahead of me. I think he had just gotten out of high school. And I've known him since he was 17, and he has a very interesting history in amateur television. In fact, he's a KCBS engineer in the LA market for commercial TV. He really knows his stuff. But back to the origins of Amateur Television Network, I was the only person in Santa Barbara that had anything to do with television at first. And there were a couple of guys, 2 or 3 guys down in LA. And we got together and we kind of whipped it up and operated Simplex for a while, decided, well, it's really important if we're going to get a bunch of people on the air, we need to put up repeaters. And so we started working on those. And I don't know how many people we had gathered together and decided it's time to form a club. And it was right around 1980, I suppose, that we formed this club. And it had a different name at first, but within a couple of years, it became the Amateur Television Network. And the concept of the Amateur Television Network is to encourage people to get on the air and to pool resources, to put together repeaters, and ultimately to link repeaters together. And so we're doing a lot of that today. There are, I don't know how many, dozens of repeaters around the country linked together, members of the Amateur Television Network in lots of different cities, primarily in Southern California. I think there were like 8 of them connected together at some point in Southern California. But we have 3 linked together in Arizona, and we connect those together over the internet. We connect to other ATN repeaters in Northern California and several states in the United States. That kind of segues into our amateur TV nets that we have.
Before the internet was widely available and bandwidth was available, what did you use in Southern California to link those repeaters together, or did you link those repeaters together?
We did link them together. At first, we just received the signal at the repeater output from a remote repeater at our local site and put it on our local transmitter. And they did the same. And there's some feedback problems if you do that. So eventually we set up microwave links between the repeaters. Some of these are over 100 miles long. Others are, 30. The ideal distance is 30 miles or less. But most of our links were in the 60-mile range to connect the different repeaters together. And so on microwaves, we connected them together on 2.4 gigahertz primarily.
This is like surplus analog microwave.
Well, let's see. I'm trying to remember what the rigs were that we started with. Well, we weren't able to get our hands on commercial equipment at the time. Eventually we could, especially when some of the guys started working in the commercial broadcasting industry. Sometimes we could get hand-me-downs as they upgraded. The microwave equipment we used is FM amateur television. It's wider bandwidth. It's more like what the satellites use. Electronic news gathering systems in broadcast television use this type of format. And it worked out very well for good quality long distance links. We just had to make sure that we could get enough power and started putting up dish antennas, 4-foot dishes, and 6, then 8. And we've got some 10-foot dishes up there now that allow us to send these wideband FM video signals long distance.
Now, are those still in place?
Oh, yes. Even in the days when we're converting to digital, we anticipate that for a long time, our RF links between repeaters will probably be wideband FM. And the quality of it it's really premium quality standard definition. And we were talking about MP3 earlier and versus, well, we didn't mention WAV files, but WAV files are typically much better quality music files. The FM video is kind of like WAV files compared to some of the other standard definition stuff that is not as good quality of signal. So, we could have sent analog vestigial sideband signals in our links, but they were lower quality. So we opted for the wideband FM signals that are higher quality. Even though they're still standard definition, they have a lot less noise and a lot better frequency response. So those FM links are going to be around for a long, long time.
And where are those sites from the farthest north to the farthest south? How big is this network that you built?
Oh, well, let me focus on the Southern California RF network, where there are about 8 repeaters that are linked together with RF. There are ATN repeaters all over the world. In fact, we have a repeater in Tasmania that is in the process of becoming an amateur television network system, and we do link to them over the internet. But RF wise, the northernmost repeater in Southern California that's RF linked is Santa Barbara, and the main hub is down in Orange County near Disneyland, not far from Disneyland, on about a 6,000-foot mountain called Santiago Peak. And Mike Collis has always, WA6SVT, has always been the major technical person on putting all of this stuff together. And he takes care of almost single-handedly, but he does have help from others as well. He takes care of installing and maintaining these repeaters on all of these mountaintops all over Southern California, and he helps out in other places too, and certainly including Arizona. So Santa Barbara is the northernmost one. The southernmost one was San Diego. There's a repeater down there now, and I'm not sure if they're affiliated right now with ATN or not.
Would that be like on Otay Mountain, and so that you'd actually have the city there? I mean, I can see all these mountains in my head because I had a repeater on Santiago Peak when I was a young teenager. But you must have like Oat Mountain or something in the valley, so you have valley coverage.
Yes, yeah, we try to find a mountain that will serve the community so that the coverage areas kind of overlap, and then we link them together, and we can cover most of the real estate from Santa Barbara to San Diego to out into the desert, actually, in California, northeast of San Bernardino. There's a repeater up at Crestline above San Diego in the mountains. And we actually have an RF link, not over the internet. We actually have an RF link from, I believe it's from Crestline, but it might be from another site all the way into Las Vegas. So we get RF video to and from Las Vegas in real time with an FM, hundreds of miles.
All these links are full duplex.
That's right. So that's a blast. And when we have our nets, we have people check in from all over. And like there aren't oftentimes on any given repeater, there might only be a couple of people operating through that repeater. But because they're all linked together, when we have nets, we'll have our Tuesday night nets. We'll typically have 25 RF check-ins because of people being linked together. And we often get as many as 25 check-ins over the internet as well, using a Zoom-like application called whereby.com. In fact, I'll let people know if you want to join us on Tuesday night at 7:30 Pacific time, go get on the internet, whereby.com/ATN1, and you will come up on a Hollywood Squares type whereby screen, and you'll all be able to see each other over the internet. But what's really cool about it is that screen or individual squares of that screen get put on the Santiago ATV repeater during the net. So once you get on that screen, Roland, the net control, puts you on the air to everywhere. And I mean that seriously, because not only do we have RF linked repeaters, but we have internet linked repeaters, and we stream full time to YouTube, So you can see us on YouTube anytime, 24/7, 365. We stream to the British Amateur Television Club in UK. We're really on the air to everywhere. So some of it's RF, some of it's over the internet, and we have a blast.
We will return to our guests in just a moment. A new way to show your support of the QSO Today podcast is to buy me a coffee. I consume gallons of coffee to create this weekly podcast. Invite me for coffee by pushing the yellow button, Buy Me a Coffee, on the QSO Today show notes page. And now back to our QSO Today. How do you translate the analog video signals to the internet, to Whereby, for example?
Well, the simplest way is we use a computer program called vMix, VMIX, and you can get that program for free with limited resources, but still it's very effective. So if you're interested, go out and download vMix and play with it. And basically, you can use I/O devices.
Like an analog capture card, for example, something like that.
You can use a capture card, or they have a thing called EasyCap. If you Google EasyCap, you'll see this device that's about 4 inches long, 1 inch wide, 1/2 inch thick, and basically it has a USB port on it, so you can connect it to your computer, and it has RCA jacks on it, so you can connect composite video up to it. Some of them will even accept HDMI input from a camera. And you put this on your computer, and then you can display several images at a time in this vMix application. And just like a television director, you can select which camera you want to output to the program output that gets connected to your TV transmitter and goes out to the repeater to be distributed on the air to everywhere.
Oh, and if you're on your computer using a digital camera, like a Logicam camera or something like that, then you'd use Whereby to join the group.
Yeah, that's the easiest way. If you want to try before you buy, get on whereby.com/ATN1 and you can get a feeling for what ATV is like.
Is that Whereby room open all the time?
Yes, it is.
You might stumble on someone who happens to be operating at the same time.
Well, what happens with Whereby is just like Zoom. It's an internet-based application. And when you connect to Whereby, you become one of these Hollywood squares, and there may be nobody out there. During the nets, there are always people. But in between, you can still go out there. You can test it, make sure that it works, make sure that your audio and video come back. But one of the secrets, and Roland has allowed me to tell the world, that if you go out there, he gets a notification that you're out on Whereby. And if it's at all possible, any time of the day or night, and he pops up at unusual times, he will come out there to say hi and chat with you, even if there's not a net in process. Boy, Roland is one of our best ambassadors, KC6JP. So if you get on ATV, Mike Collis and Roland Hoffman will become your friends very quickly.
How about that? And he doesn't need any sleep.
He does. In fact, he runs a very elaborate business. So he's very and he's a bicycle nut. He gets up really early in the morning and gets on the internet for some kind of cycling class that he does every day. And in this class, it's kind of a virtual class. They have these exercycles in their houses, and they can put their stats and their video up on.
Oh, it's like a Pelotron.
Yeah, I don't know that much about it.
It's a cycle that comes with an app and classes and communities. I guess you can even race each other.
Yes, and it's like Pelotron, but I'm pretty sure it's not Pelotron. But they get on there, and before most of us even wake up, these guys have bicycled 70 miles. That's how serious they are, and it takes all of the exertion on these cycles that you would put out if you were actually bicycling miles. Boy, he loves that. So he's passionate about a lot of things, and very interesting and amazing.
He can do the miles without having to worry about getting hit by cars or anything like that. Potholes, no potholes on his route in the morning.
No, I don't think so. I think it's the perfect bicycling scenario. But I don't know if he does this, but when you're on a bicycle and zooming along, you have the wind passing over your face, things like that. And that's all part of the experience. Maybe he sets up fans.
Could be. What is mesh video?
Ah, yes. Along comes this another specialized mode that Rod hears about and says, I've got to do that. And it's called mesh networking. And it started out maybe somewhere even 15 to 20 years ago. The ARRL had a group of people that said, well, let's try to do something with broadband digital on amateur on amateur radio. This wasn't video at the time. And so they started out a mode called HSMM, High Speed Multimedia. And I heard about this, and just like I got into ATV, there was a good friend of mine in Santa Barbara, and we dared each other to get on HSMM and see what we could do with it. And so we used Linksys routers at the time. A certain model of Linksys router could have this specialized firmware loaded on it that would allow them to operate within the regulations of amateur radio, automatically IDing and doing everything legally for amateur radio. And we set up a couple of these devices on the ends of a table, and we had them talking to each other. And it was really in its infancy at the time. We found that we could put an application on there on our computers connected on both sides. And it's not very much different than people are running Wi-Fi now in their house, but it's all on amateur radio and it doesn't require an internet. So we installed this application on each end called Mumble, and Mumble allowed us to transmit voice over the mesh network, which was only 2 items at the time, across the tabletop. We could hear each other on the other end. It was kind of like talking into cups with a string connected, but it was a lot higher technology. So that's how it got started, and we couldn't talk anybody else into getting interested in it. Just didn't have enough pizzazz at the time. And a few years passed, and HSMM became BBHN. I can't even remember what that is. It's broadband
ham network
or high-speed network, one of those. So they kicked it up a notch, and they made it work better, and they may have even started using different devices that could run higher power and so on. And that was around for a little while, and then there was a spin-off from that. Some of the people that were developing that wanted to progress with the technology faster than some of the people who wanted to kind of keep it was. And those people that were on the bleeding edge again formed a group called Arden, AREDN, pronounce it Arden. And they developed new firmware, and then they got really busy making that firmware work on ubiquity access points. And so that really opened the horizons. So mesh networking really came into its own because these ubiquity devices had a lot of better capabilities than the original Sys. The Linksys ones were running like 30. The ubiquity devices were running 600 milliwatts to a watt of power. And with dish antennas, you could go a long ways with low power on this mesh network. So getting back into mesh video. So you connected a computer to these things on each end, and just about anything you could do on a computer and push through a Wi-Fi port, any application, you could send from one node to another, and these radios would automatically connect to each other. If you had 10 hams, put them up, and they were all within range. As soon as you put them up and plug the power in, the software that was built into these things is smart enough. It will, as long as the parameters are the same for all of the devices. I can talk more about that, but keeping it relatively simple now. As long as they're the same, they'll automatically connect to each other, and you don't have to do anything. And you leave them powered on all the time, and they're just talking to each other to make sure that they maintain the connection. And then whenever you want to, you hook up your computer to it, run an application that shows a list of all of the nodes that you're connected to, all of the radios that you're connected to. And each of these radios can have programs running on them or programs accessible from them. So you can connect to a node 10 miles away that some other ham put up, and he will maybe have put up an application called Mesh Chat, which is the most popular. And what you can do is you can open up that Mesh Chat application, type in your call sign, and type a message that gets put on a bulletin board. And that bulletin board basically gets shared between other nodes that are running the same Mesh Chat application. Within minutes, the message that you put on one gets replicated to all of the other nodes. Now, so there are a lot of applications like that. That's the simplest. There are applications where you can talk over the mesh network, and there are applications where you can send a video over the mesh network. Some people just put up webcams, and you can go to their site and you can open up their webcam, and you can either see the view from their yard, or you get a picture of their ham shack. Sometimes they're not there. Sometimes they're operating. In Mesa, Arizona, our net control on our we have a mesh network every week on Thursday. He gets on there and we talk to each other on FM, but he has a webcam active so we can see him operating with video through his webcam. One of the best applications is called Team Talk, and Team Talk allows us to do all of the functionality of video conference. Okay. And if you, with a video conference, you can certainly send video back and forth. You can send audio back and forth. You can send files back and forth. You can chat by typing on the screen and see, the typed message comes up. And you can do virtually everything with Team Talk. So I think that kind of answers your question about what's this mesh video all about. And so you can transmit video over the mesh. Now, the one thing that's worth mentioning here is not only can you transmit video over the mesh, which is another form of amateur television, but you can connect mesh video to other amateur television like our ATN repeaters, and you can connect video from the ATM repeaters to the mesh. And so, that's the thing that I left out before when I said we're on the air to everywhere. Not only do we stream to YouTube, but we stream over the Arden mesh network. And so 24/7, you can see the output of the Santiago ATV repeater on your mesh network.
When we're thinking in terms of the amount of bandwidth, does that use a little bit of Arden, or does it use a lot of Arden? If you have your net running with all these nodes going, are you taking down the network, or does the network just have so much bandwidth that you're able to coexist with all the other users?
Well, you don't take down the network. You can degrade the network on a segment of the path. Of course, you have nodes scattered everywhere. There's an area in the Phoenix metro area that we call East Valley. And I live in Mesa. It's about 25 miles east of Phoenix, but it's just a suburb. We're all connected together. But most of the activity in our area grew up out of the Mesa area through the Superstition Amateur Radio Club. And now we've expanded that group to be statewide. We call it Arizona Mesh Organization. And we're involving mesh networkers from a lot of other communities. But in the East Valley, we have about 50 nodes that are active at any given time, and they're scattered all over. Each ham that gets on mesh networking puts something up on their tower or the best location they can. One challenge is a lot of people are in HOAs. And they have to shoot through their windows and things like that. But if you have somebody close enough, you can still make a good connection. Back to using up the resources of the network. So if you're on talking from one node to another, and there's no ATV or there's no mesh video going through that node, you have full bandwidth, okay? But if you're transmitting through some shared nodes with people who are running video, the video takes up a lot of the bandwidth. And one of the downfalls of mesh networking, even though it's broadband, it doesn't have enough bandwidth for distributing a lot of video to a lot of places. So the real forte of mesh networking is getting video from one place to another inexpensively, digital video that looks and sounds really good. And it falls down in the distribution. If you're just going from one point to another, that's great. And for public service, a lot of times that's all that you need. You want a remote camera visible at a central site. Complementary to that is traditional amateur television, amateur ATV repeaters, where their forte is distribution, where you have somebody transmit into a repeater, and that repeater transmits simultaneously in real time to cover a very wide area, not to mention the streaming aspect of it. And so you're sending that signal to the repeater, and the repeater distributes it everywhere. So the best of both worlds is to have either ATVers as the source or mesh video people as a source, connect that to the TV repeater for distribution. And like I say, you have the best of both worlds. So that's what we're trying to do in a lot of, we're trying to make that integration grow. And we've had really good results with it, but we don't have that working everywhere.
The advantage then of the mesh is that because there's so many people doing it, that even with an HOA where you're shooting a signal through a window, perhaps, because there's somebody close by, that becomes the next node over. So it's kind of a self-healing network. If another person disappears but somebody comes on, then it reroutes the traffic and you're back in the net.
Exactly. So that's what mesh is all about. The concept of mesh is like you put your fingers and both hands together and they mesh with each other, and there are a lot of intersections. The concept of the mesh network is that ideally you want to make a connection to, and let me point out at this point, I'll elaborate later, you want to make an excellent quality connection to at least two stations. And when you do that, each station will connect you into all of the other stations that they can connect. But the mesh concept of redundancy allows you to have a station go down, and because of the nature of the mesh network, everyone being connected to everyone else, you can have a station go down and you kind of lose that path, but you have a redundant path into the mesh network. So you're still connected to pretty much everybody else. And that makes it really helpful during disasters when you just never know what's going to work and what's not going to work. Disaster communications in the beginning was what really drove all of this mesh networking. We don't have enough disasters to keep these things all busy, thank goodness. So we set the networks up so that they can function well in a disaster. And in the meantime, we have a lot of fun with it.
Rod, what do you think the greatest challenge facing amateur radio is now?
Well, amateur radio or amateur television?
Amateur radio in general. I mean, from your perspective, obviously you're looking through the lens of amateur television, but if you're looking at amateur radio as a whole, what do you think the greatest challenge is?
I'm still active in many, many modes of amateur radio. So even, a lot of people say I'm Mr. Amateur Television. Some people say I'm Mr. Mesh Network. It depends, where you are and what your exposure is. But I'm a member of probably a dozen to a dozen and a half amateur radio clubs, and I try to support them and participate as much as possible. I think the future of amateur radio is very bright. I'm far more optimistic than a lot of people are. A lot of people see one of the hazards of amateur radio being that some people call it an old people's hobby. Old people get old and die off, and there are people out there that think that the numbers of people active in amateur radio is decreasing, and that is not true. There are more radio amateurs today than ever before, and there are more active radio amateurs, and there are more interesting things and valuable things to do on amateur radio. And you have to keep in mind, when all else fails, there's amateur radio, and that is very valid. Some of the things that we're facing today, like Ukrainian invasion and all the possible fallout from that, that's pretty scary stuff. The Cold War is heating up again, and especially with cyber attacks that are possible, we could all of a sudden find ourselves without a grid, with no notice whatsoever, or have other serious problems in the way that we conduct day-to-day business. So we need amateur radio, and we have amateur radio active enough so that we can fill a lot of gaps there. So I think the worst thing, the riskiest thing, I can't remember exactly how you phrased your question about ham radio, is people not opening their eyes and seeing what's real out. this is a great time for amateur radio in all aspects of it. It's very exciting. And amateur television is like 10 times as exciting as it was 10 years ago. So I encourage people to, get on Whereby, see what we do, and then see, what else you might want to do there. Get on mesh networking, see how that works. In most communities, there are very active mesh network people and groups. They'll help you get started. Mesh networking is a very inexpensive way to get started with, great return on investment and a lot of things that you can do with it.
Well, I asked about what the greatest challenge is, and I think you answered it in a different kind of way. I think that perhaps what you're saying is that the greatest challenge that amateur radio operators may have from your perspective is that they're not thinking big in terms of what amateur radio has become. They still may think that it's, something very narrowly defined like CW or single sideband. But I often say to people on this podcast that ham radio has become this three-ring circus, but it has a midway with 1,000 tents now. If we get out of the big tent and look at all the 1,000 tents, like we will find mesh networking and software-defined radio and amateur television and all this amazing stuff that's happening. You mentioned earlier before we started about the Santa Barbara hackerspace, and I can only imagine that the hackerspace includes things like 3D printers, which are now part of amateur radio, and Arduino controllers and Raspberry Pis. So I think I'm interpreting what you're saying, that the greatest challenge is that a lot of hams don't think big.
Well, and it's not only thinking big, it's thinking realistically. Their exposure to ham radio may be way out of date and very unrealistic. I want to make a point of talking about young people in ham radio. And the technology has changed a lot. So, you have people still operating AM on HF, and they're having a lot of fun, and there's nothing wrong with that. And as long as they're happy with that, that's great. But that's not the only thing there is in amateur radio. In mesh networking especially, we're integrating Raspberry Pis. A lot of these applications I talked about are running on Raspberry Pis that are connected to these mesh radios. And there are a lot of young people that are getting involved in this. And I want to go back to this cell phone. Remember early on, I said that cell phone is one of my favorite amateur radios. And the beauty of that is it operates on a legitimate amateur radio band, 2.4 megahertz. And you can send Wi-Fi over it, and I can use it to communicate with mesh networking. Probably 90% of the mesh networking activity that I have uses the cell phone as an I/O device, an input-output device for audio, video, files, data, all of that stuff. So and young people are all about cell phones. So when people find out that they can use their cell phone to get on ham radio and do fun things, that gets some of the younger people involved. And there are still schools with ham radio clubs, and there are teachers. Teachers are wonderful for getting young people involved in amateur radio. So I think when you talk about challenges, the biggest challenge is get the real information out there and get people to see what's going on and try it. And if you try any aspect of it, go to a field day. If you're not a ham, go to a field day. They'll have a station set up where someone will put you on the ham radio. You can make contacts during a very busy contest. It's really not a contest, but a very busy event when there are lots of stations on, and you can see the excitement, and you can operate the radio even without a license, as long as it's controlled by another licensed radio amateur.
You mentioned using your cell phone on ham radio. Are you saying that there are amateur radio applications that will actually allow you to connect to amateur mesh on the Wi-Fi band? I mean, are you actually using the Wi-Fi radio in the phone to talk to amateur mesh networks?
Well, not exactly, but there may be applications out there that do what you're talking about. I'm not familiar with any that have cell phone directly talking to another cell phone without going over the internet. That's certainly practical if somebody put an application together. And I think there are some.
Or no, I'm talking cell phone talking to the mesh network, on 2.4.
what we typically do is we have the cell phone Wi-Fi talk to what we call a gateway device. And the gateway device is a little Wi-Fi repeater, if you want to think about it that way, that receives your 2.4 gigahertz or 5 gigahertz Wi-Fi from your phone and then connects it to another radio, basically, that is configured to talk directly to the mesh network. So it just takes in the Wi-Fi and connects it internally to the mesh network, and then you're talking on the mesh network.
Right, so you might have a mesh network transceiver, like a Ubiquiti rocket or something connected to an antenna up on top of the roof or whatever, but at the bottom you've got an Ethernet cable that runs into a regular Wi-Fi device that the phone can talk to.
Basically, that's it. You need a gateway device with basically two radios. One of the radios will connect to your phone over Wi-Fi, the other, and then it's internally connected, and the other radio connects directly to the mesh net. And so you just, you do whatever operation you want, talking, sending video, typing, any of those things on your cell phone, and it goes through this gateway device, and it's right out there on the mesh network. You can look at the cell phone and you see the same screen that you would see if you had your computer connected to the mesh network. And so you see all the nodes and you see all of the applications that you can run.
Mesh chat and team talk and the things that you mentioned before, those things are available as apps on the phone?
Sometimes you download the app to the phone and then that app talks to a server that's out on the mesh network. You're actually doing all of this stuff with your phone. Like your phone is an I/O device. It's kind of like a wired telephone. You pick up the telephone, it's an appliance that's connected to the phone company. Well, the cell phone functions the same way. It's not unlike having a microphone connected to ham radio. It's all part of the system, but it's so flexible. The cell phone can do everything. And so as an I/O device, it's perfect. Everybody's got it with them all the time. It's just really cool, and young people relate to this really.
And you could use your Whereby app on the regular 4G LTE network, right?
Absolutely. And so a lot of times if I don't feel like getting out of my lazy boy to go to my computer or where I've got my better video set up and all of that kind of stuff, I'll just rock in my lazy boy with my cell phone and have to hold, I actually need one of those selfie sticks. So I hold the camera up so that they can see me and I can see all of them on the screen. And it's the same experience, just on a smaller computer. That's all.
Well, Rod, it has been a real pleasure to have you. And all of the questions I would ask in terms of advice and stuff you've already given. So I'm not going to ask those questions. Instead, I'm going to thank you so much for spending time with me today and wish you 73. Thanks for coming to QSO Today.
73 to you, Eric. Thank you for doing this. And I love to see everyone sharing their passion of ham radio.
That concludes this episode of QSO Today. I hope that you enjoyed this QSO with Rod. Please be sure to check out the show notes that include links and information about the topics that we discussed. Go to www.qsotoday.com and put in WB9KMO in the search box at the top of the page. Be sure to click on the Expo menu item on the top of the home page for more updates on the upcoming QSO Today Virtual Ham Expo on March 12th and 13th, GMT. I am updating it as I have more information. My thanks to Icom America for its support of the QSO Today podcast. Please show your support of Icom America by clicking on their banner in the show notes pages. You may notice that some of the episodes are transcribed into written text. If you'd like to sponsor this or any other episode into written text, please contact me. Support the QSO Today podcast by first joining the QSO Today email list by pressing the subscribe buttons on the show notes pages. I will not spam you or share your email address with anyone. Become a listener sponsor monthly or annually by clicking on the sponsor buttons on the show notes pages, or use my Amazon link before shopping at Amazon. Amazon gives me a small commission on your purchases while at the same time protecting your privacy. I'm grateful for any way that you show appreciation and support. It makes a big difference as I head towards episode 400. QSO Today is now available in the iHeart Radio, Spotify, YouTube, and a bunch of other online audio services, including the iTunes Store. Look on the right side of the show notes pages for a listing of these services. You can use the Amazon Echo and say, Alicia, play the QSO Today podcast from TuneIn. My thanks to Ben Bresky, who edits every single show and allows both this host and my guest to sound brilliant. Thanks, Ben. Until next time, this is Eric, 4Z1UG, 73. The QSO Today podcast is a product of KEG Media Inc., who is solely responsible for its content.